So my name is Gabriel Masei. I'm a senior C++ developer at One and One Mail and Media, and I'm also a contributor to Collabora Online and LibreOffice projects and communities since I think 2018. And today I will talk about deploying Collabora Online on a large scale. Okay, in One and One, we are using Collabora Online for our online office applications. We are offering two services, viewer and the editor. Both are based on Collabora Online. The viewer uses CoolConvert to REST API to convert documents to PDF, and then the PDF is displayed in front end. And of course, the editor provides the entire set of editing capabilities that Collabora Online provides. So these two services we are using in the cloud, so our users which are storing the documents in our cloud can view and edit the documents through these services, through these applications. Also email, we are using email attachments, also for viewing and editing the attachments. And also we have a feature called hybrid mail, which allows you to which allows a user to send a letter, a physical letter to a physical destination address directly from our online office application. The role of the Collabora Online here is to convert the letter to PDF, which is sent to Deutsche Post, and Deutsche Post takes care of, prints it and takes care of delivering to the destination address, physical destination address. Okay, let's talk a little bit about the scale of deployment. I think One and One was the first one who deployed Collabora Online through Kubernetes. Why we are using Kubernetes? Because the scale of deployment is pretty large. And in this case, we need to use a powerful tool that could help us to handle that deployment. So we have more than 50 pods for the editor, more than 50 pods for the viewer, one cool instance per pod, 2 cores per pod, a limit of 6 gigabytes per pod. And our experience is with our users is that more than 600 documents are edited at the same time. 600 is, let's say, on the lower half of the interval of usage. We sometimes experiencing usage of close to 1,000 documents edited at the same time. In 24 hours, there are more than 35,000 documents edited. And in viewer, we experience around 600,000 conversions in 24 hours. Okay, so as you can see, the deployment is pretty large. Okay, in terms of volume of instances, of number of instances of Collabora Online, and in terms of usage from our user side. Okay, so in order to handle well that large scale of deployment, we are using a specific architecture, which you can see here is made of two sides. So we have a client side which renders cool data HTML in an iframe and displays it to the user, integrates in our online office web user interface. And also we have a server side which is made up of multiple components. The most important ones are shown here. So we have a middleware, which is a proxy, which handles connections from clients and redirects them to Cool. Okay, it behaves like a proxy, but also it makes some other tasks like balancing and so on. Collabora Online also is another component, of course, and the other component is storage adapter. The role of storage adapter is to convert from WOPI protocol to our internal protocol. Okay, so our cloud does not understand WOPI protocol, so we have to convert requests from Collabora Online to cloud and the other way. Okay, so its role is to make this conversion. These three components that you can see here inside that red rectangle, all of them are deployed through Kubernetes. Okay, so not only Collabora Online, but also the router, the storage adapter. Of course, the biggest number of instances is on Collabora Online side. Okay, the other components have much less instances. Okay, so let's discuss a little bit about one-on-one contributions for large-scale development. Okay, so we shared some of our implementations that helps us to handle this deployment. We shared with community. Okay, so we will discuss about three of them. I think the most important one of them is we provided a basic support for Kubernetes some time ago, of course. In the meantime, that first implementation was expanded. So how the deployment works? We are building a Docker image, okay? Then we are packaging the Helm charts, and then trigger deploying Kubernetes. Kubernetes uses the Docker uses the Helm charts to configure the system, the environment, where the containers from based on build Docker image are deployed. So our project, our contribution was to provide some Helm charts, okay, as a basic setup for everyone wants to, as a starting point for everyone wants to use Kubernetes to deploy Collabora Online. The Helm charts are residing in Kubernetes folder. Of course, when we didn't provide with a proxy. As I discussed a little bit earlier, we have a proxy, a middleware. Okay, we didn't provide support for that, but in the meantime, as far as I know, Pranam added support for Nginx and for HA proxy, I think. If I'm mistaken, correct me. Of course, on our side, we don't use Nginx and HA support. We are using a custom proxy because of the particularity of our needs. Okay, but all of them can be used successfully. Okay, I mentioned earlier, but let me mention again that the proxy is needed for balancing and for handling collaborative editing, at least for these tasks. Okay, on our side we are doing multiple tasks. Another contribution was a REST endpoint for statistics. Collabora Online, until we shared this implementation for a REST endpoint, Collabora Online offered and is still offering the admin.html endpoint. Okay, that is a really nice tool to see some statistics, to evaluate the behavior of the application. However, on a large scale deployment, you need something automatic. You need something simple and something that could be processed by some tools in an automatic way. Okay, so that's why we created that REST endpoint, because we are using Prometheus as a tool for evaluating these statistics and providing them in a in a nice way, let's say, through Grafana. Okay. So the endpoint is /cool/get metrics. The metrics are provided in a simple Prometheus compatible format. The Prometheus format is a little bit more complex, but we are providing the statistics in a very, very simple format. On the right side, you can see an example of some statistics. Okay, so it's usually it's name of the statistic followed by a by a number, by a value. It's difficult to say that this is a format, but this is the, let's say, the basic format of Prometheus. Okay. The statistics are different. We provide values for total, min, max, average. Why? Usually, if you have some tool like Prometheus or Grafana, that tool can store data for different time frames, and it could provide a minimum, a maximum, and an average. But sometimes you don't have that tool. Okay, you don't have access to that tool, so you need to see immediately what is the max value or mean value or an average value. So I think that is useful in this case. Statistics are some global statistics about, for example, global memory, statistics about processes, CPU, memory usage, threads, number of threads. This could help in evaluating the performance of the application and also could point security issues and so on. At document level, counting the documents, views, some network activity, okay. The amount of data exchange between client and server through WebSocket connections, download, upload duration, load duration, open duration, how time a document was opened, was in an open state. Okay, some errors, some statistics about errors. Thank you, Michael, for providing those statistics. And also cleanup statistics. And now we will go to the third contribution that I think it's important when having a large-scale deployment. As with the metrics, when you have a large-scale deployment, you need automation. Okay, you need automation because if you have 50 pods to handle them, to study them, it's very difficult. So you have to implement some automatic tools and features. And since Collabora Online is based on LibreOffice Online, which is a very complex application, of course, it's not something unusual that the application from time to time has some issues, okay, and especially on kit process side, because kit process loads the LibreOffice application, which is very, very complex. And from our experience, we've seen that most of the problems were coming from there. So we decided to implement some automatic mechanism for cleaning up, let's say, problematic kit processes. Okay, problematic kit processes could mean multiple things, but we focused on two types of problematic kit processes. The kit processes which are not handled anymore by cool WSD, they are useless. Okay, they could be removed, and also resource-consuming kit processes. They are still up and running. They are still referenced by cool WSD, but they are consuming a lot of resources. So we decided to implement this cleanup features and share it with the community. Okay, I won't dig into details. I kept a presentation on this topic at Cool Days 2021. You can find it on YouTube. Okay, it's called Stability and Cleanup Improvements in Online. If you want to know the details about this